Hey guys, welcome back to the channel. Today I'm gonna walk you through a scenario where we need to handle multiple data retrieval operations without enabling Mars or multiple active result sets in SQL Server, actually in your connection string. And before we dive into this approach, I'll start with a quick introduction to Mars and why developers find it useful. Then I'll show you how to structure queries in a way that makes Mars unnecessary. If you are new here, make sure to check out my previous video on how to use Entity Framework Core effectively. In that video, I covered the essentials for structuring EF4 applications, optimizing query performance, and avoiding common pitfalls. The link to that video is right above this page, and you'll find the project source code on my GitHub, so feel free to download it and follow along. Multiple active results sets or MARS is a feature in SQL Server that allows multiple queries to run on the same connection simultaneously. When enabled, MARS helps you execute concurrent queries and retrieve data without creating a new connection for each operation, which can improve performance and reduce connection overhead. This is especially useful in applications that need multiple queries running at the same time. But here's the catch. Although Mars can be a lifesaver in these cases, it has a downside. Enabling it can increase memory and CPU usage, potentially leading to issues in high traffic applications. For this reason, our goal here is to avoid enabling Mars by designing efficient queries. Sometimes, if queries are poorly designed, enabling Mars can help retrieve data from SQL Server, but it's not always the best approach. Instead of relying on Mars to handle concurrent queries, you may want to redesign your queries to reduce unnecessary load and pressure on the database. So let's dive into our project and explore how to address this issue effectively. Okay, this project picks up from our last discussion on boosting EF core performance, where we covered key optimization techniques to improve query efficiency. If you haven't checked that video out yet, I recommend you watch it for an understanding of the base project setup, which includes several foundation optimization tips. I've made a few updates to the project. Specifically, I've added two new tables, customer and order, along with their respective entities. We have established a foreign key relationship with customer ID in the order table to simulate a real-world example where customer and order records are linked. This setup allows us to illustrate scenarios where Mars or multiple active result sets might come into play, and more importantly, how we can handle concurrent query situations even without Mars enabled. So let's jump right into it and explore these updates to see how we can optimize query performance while minimizing database load. Okay, here I've added the customer repository class that encapsulates data access logic for customer entities. In this repository, get customers with orders provides a specific method to retrieve customers along with their orders, centralizing this logic and separating it from the application's business layer. Also, the customer service class would be responsible for business logic around customers, including calling get customers with orders. By placing this logic here, your application has a clear division of responsibilities between data access and business logic. And finally, the customer controller class will expose the service method via an API endpoint. In the controller, you might have an action like get customers with orders that invokes customer service that get customer with orders, and this allows external requests, for example from clients or testing tools like Swagger, to call the service and retrieve the data. Okay, here's our method designed to retrieve customers along with their orders. As you can see, we are using concurrent requests like this and this with just a single open database connection. This line asynchronously retrieves all customer records from the database, storing them in the customers list. The toList async method helps ensure non-blocking execution, enhancing efficiency. Here we create a list of customer ID values from the customers list. This list represents the IDs of customers for which we will later retrieve related order records. This line defines a query to fetch order records where the customer ID matches any ID in customer IDs. This step fetches orders related to our customer list without yet executing the query. And here in this loop, we execute a query to filter orders to those matching the current customer ID. And then we assign the resulting order list to customer.orders. And this line completes the association between each customer and their respective orders. And finally, we return the list of customers now populated with their associated orders. As you know, this method hasn't been implemented in the most efficient way. My goal here is to demonstrate what happens when we run concurrent queries using a single database connection without enabling MARS or multiple active result sets. So let's test our endpoint to see the result. First, run the application. Okay, click this button and then hit execute. As you can see, we encountered an error message indicating there is already an open data reader associated with this connection, which must be closed first. This error arises because with MARS disabled, only one active data reader is allowed per database connection. Since we have multiple asynchronous operations, such as loading orders while iterating over customers, MARS is needed to allow concurrent data access. To resolve this, set multiple active result sets true in the connection string. After setting these to true, we can run the application again and test our endpoint. This time everything works perfectly and our endpoint returns data without any issues. While enabling MARS allows you to retrieve the result, it's not the most efficient or effective solution. As I mentioned earlier, this approach increases resource and CPU usage, which can lead to issues in high-traffic applications. Additionally, if you are working with EF Core and encounter this error requiring MARS to be set to true, is a sign that the query design may need improvement. In EF Core, enabling MARS is typically unnecessary, and instead of it, you can leave it set to false and redesign your query to optimize performance. Okay, let's modify our query and keep MARS set to false. I've set MARS to false and we'll go to the customer repository file to start improving the query. Here, I've used two queries, one to fetch customer data and another to fetch order data. Rather than this approach, I can remove all this code, including the for each loop, and use the include method to fetch order data directly. This simplifies the query design, eliminating the need to enable MARS. Now let's start the application and test our API. We can see the application retrieves the customer and order data efficiently without any connection conflicts or performance issues. This redesigned query provides a streamlined data fetch, reducing resource usage and improving stability, especially important in applications that experience high traffic. By extracting our query this way, we've optimized our API to handle concurrent data access without needing MARS, leading to a more robust and scalable solution. Also, you can find the source code for this project on my GitHub account, so feel free to download it, explore and experiment with the methods we covered today. If you found this tutorial helpful, please consider liking this video, subscribing to the channel and hitting the bell icon so you are notified about future videos. Your support really helps in creating more content like this. Thanks for watching and happy coding.